Hi guys, and welcome back to Learn Extra Live Maths Lit. I hope you're all having an awesome time and you're chatting to us on the page. I see a whole bunch of you are starting to post. We're still laughing about Lindy's cup of coffee. It was delicious. We smelt it through the screen during the break. So, Hayley, take it away.
Thanks, Indy. Right, guys, let's start with question 3. So we've got a circular glass tabletop. It's attached to a glass stand as shown in the picture below. So let's look at the picture. Right, there's our table. The radius of the circle is 68 centimeters. Really important fact. The stand is made from 3 rectangular pieces of glass that have, so those are those 3 pieces of glass there, hope you can see them in our picture, that have a length of 1,65 meters and a breadth of 55 centimeters. Now, Indy's just looked at me and we're laughing a little bit about this 1,65 meters because clearly the table, there's got to be a typo, a mistake somewhere in this calculation because 1,65 is about as tall as I am. But we're going to go with the maths.
We had a nice little laugh about that. I was like, well, maybe it's really high table. And then we just realized, and then they're like, no, Indiana, no one's going to
sit at the table. But you know what? We've been given a calculation. So even when they don't make 100% sense, you know what? We're going to carry on doing the question as if that makes total sense. The glass components have a thickness of 60 millimeters. Now, the first thing that is standing out in my mind is that we are dealing in meters, we're dealing in centimeters, and we're dealing in millimeters. And that's our bells going off, and that we need to change those. We're not going to change them quite yet. We'll change them as we need to. Right. To protect this and strengthen the table, it is recommended that you apply a thin covering called Durafilm to the glass surface. So we need to calculate the area of the Durafilm that you need to cover the circular edge of the table. That is the circular top of the table. So let's see. And this particular question, we haven't been given the formulas. So I'm going to give the formula. The area of a circle is your pi times your radius squared. Now remember, we had our radius. And I'm going to work everything in centimeters. So let's... our radius was 68 centimeters. So my area is 3,14 times 68 squared. Get our calculator out. So it's 3,14 times 68 squared. And we get an answer of 14519,36. Right, 14519,36. So that is, but now don't forget your units. We're dealing in area at centimeters squared. So let's move to the next part of the question. Right, the next question says, calculate the area of the Durafilm you will need to cover all the glass components that make up the stand. So we're looking at the stand. So our stand has got 3 pieces of glass, but in actual fact, we've got 6 sides to the glass. So we're going to do our length times our breadth of our rectangle. So I always like to draw the little rectangle. So we had, this was 1,65 meters tall, and it was, I think, 55 centimeters. 55 centimeters in length. So this is my first step. I'm going to change that into centimeters. So 1,65 into centimeters times by 100 gives me 165 centimeters. So my area of one side is going to be, my area is my length times my breadth. My length is 165 times 55. Let's get that answer. A little bit more space. So 165 times 55 gives me 9075. So 9075 centimeters squared. And now remember that was one side, and I've actually got 6 sides to this piece of glass. So I'm going to times that by 6 to get our final answer of 54450. 54450 centimeters squared. Now that's covering everything except for the tiny little strip on top and the tiny strips on the side. But I think we'll get to those later. So I've covered everything except for the strip here right in the front and these strips on the side. Let's move to the next part of the question. Why do I have a feeling I left out part of a question?
Oh no.
I'm going to go back. That definitely was all done. I think on the first part. No,
While
I
you're
don't
trying
know.
to find it, I'm just looking here on the page and I'm laughing. It's quite funny. Doctor says, he says, guys, sometimes your answer has to make sense. You can't leave 89.5 boxes as your final answer. So we had a laugh about that, which is completely true. But then we've got Musa, and Musa's told us, she said, that's very true. You remind me of someone in my class today that said that he gets 16,4 penguins as an answer. Guys, you can't get 16,4 penguins as an answer. Hey, round it off.
Absolutely. And that's what's so crucial about Maths Lit, actually, Indy, is that really the context is really important. Now, I actually had a calculation which I was doing with my daughter, who's 11, so she's in grade 5, and they've just started to learn about decimals and rounding. And one of the questions was they had an oil bottle, and it was 5.95 liters, and they said round off to the nearest liter. Now, I know logically it tells me that it needs to become 6 liters. But I went to the teacher the next day and I made her laugh because I said to her, you can't round it off to 6 liters because the bottle of oil will overflow.
Yeah.
So, okay, but in grade 5, I think they just wanted an answer of 6. But you have to think, and that's what I love about the subject, because you're always thinking about what is the real life context.
Yeah.
I can't put more oil into the oil. Can't have a portion of a penguin. What
You
if I'm thinking?
can't. That's just cruel.
I don't think I missed out any questions, so let's carry on. We need to calculate the volume of the glass tabletop. So, our volume of our glass tabletop, we had already worked out the area, but in fact, our volume is, right, pi r squared times the height. Well, it doesn't look like an r. So, it's 3,14 times my radius of 68 squared times my height. But now in this case, what was the height of my shape? That was the thickness. That's the height. The height is that tiny little thing there, and it's 60 millimeters. I need to convert that into centimeters, so it becomes 6 centimeters. So my volume for this tabletop is times by 6. So let's get an answer for that. Get our calculator out, and it was 3,14 times 68 squared times 6, and we get an answer of 87116. 87116, and we're dealing in centimeters cubed. We've got to calculate the volume of the stand. So now we're going to calculate 1, and remember we've got 3 parts of the stand. So we're going to calculate 1, and a volume of 1, and then we're going to times it by 3. So our volume was length times breadth times height, and our length in this case was 165. Our height we said was 55. I think we got those the other way around. And again, our thickness was 6. So we're going to do that calculation, and now all of those we need to times by 3. So let's get our calculator out. So it's 165 times by 55 times 6. I'm going to get an answer 54450, and I'm going to times that by 3 because there are 3 glass pieces. So 163350. And again, what are we dealing with? Centimeters cubed. So have we answered the question correctly? We've said the volume of the stand. Let's see if we move on to the next part of the question. Now, the next part is, what are the dimensions of the box that a fully assembled table can fit into? So now we need to look at putting this whole thing into a box, fully assembled. So what we're looking for is the length and the breadth of the box are going to be the top of your table. So if I put it into the box, let's imagine the box that way, and I'm going to put my circular part is going to give me 2 dimensions of the box. So what do I know about this? I know that my radius was 68. So my diameter here is 68 times 2. 68 times 2 is going to give me 136. So my box, let's draw our box here. So we've got our box, we need a length, we need a color here. A length, we're going to have, doesn't look like an L, a length of 136 centimeters. Go back to this, so that's 136. And I need a breadth of 136, because remember it's a circle, so it fits into a square shape. And finally, my height, which is kind of going out of the board or into the board, is going to be that part there. And that part there was the 165 centimeters. So my dimensions are 136 by 136 centimeters by 165 centimeters. So those are my dimensions of the box. Now you can write your dimensions like this, or you can actually say, well, the length was 136, the other breadth was 136, and the height was 165. How much packing material would be needed to add to this box to protect the fully assembled table? Now what we need to do for this one is we need to work out the volume of this box. And then to work out our total volume of our table, which we've done in 2 steps earlier, and minus the 2. So let's see how far we get. I'm not sure how much time we have left. So let's see how far we can get. We're going to work out the volume of the box. So let's get our calculator out. And we're going to say, right, 136 times 136 times by 165. We're going to get an answer of, right, 3 million, and we're dealing in big numbers. And the reason we're dealing in big numbers is because I've been dealing in centimeters. You could have changed this and worked all in meters, and it would have maybe made it a little bit easier, but I'm happy in centimeters. So 3,051,840. 3,051, no, I've lost that, 840. Those are centimeters cubed. And I'm going to minus. And in actual fact, I'm not going to do the calculation, but remember we did the calculation of the tabletop, the volume, and we did the volume of the 3 pieces for the stand. So we would minus the tabletop and the stand. I'm not going to do it right now for you. And you would get a total. And the balance is what you need is your packaging material that you need to protect this table. So I think that, I think that that will give you enough information for you to finish this on your own. And I might have enough time to just say, would you recommend this to manufacturer? Now, what I'm going to tell you is that you're going to end up with a huge amount of wasted space and a huge amount of protection material that you need. It might be better to actually flatten this and send it as the tabletop and the 4 stands. You're going to need a much thinner box, and you'll have much more less wasted space. But on that note, I think I'm going to have to say goodbye to you and hand you over to Indy, who's going to say goodbye.
Sheesh, I can't believe. Is this the end of the show?
I
It's
can't
gone
believe
so
it.
fast. We've enjoyed it so much. Tiny says, love the show. Keep up the good work. YOLO to all the mindsetters. So YOLO back, mindsetter. And I hope that you really enjoyed the show, learning more and learning extra.
What else have we got on the page?
And Steffi said, this last question, she actually had the exact same question in her exam about the table, and I did say to her, I said, was the table that high? And she said, yes, but it wasn't that tall.
It wasn't that tall.
It wasn't that tall, so there must be some kind of like error. But we still worked it out anyway.
I actually think that what we did, who did you say said that?
That was Steffi.
Steffi, we had this question that actually based on a question that I've also seen before with a tabletop, but if you'll notice and go back to your exam, you'll see that we've actually changed the question slightly. And I think that's where our gremlin of our 1.65 meters actually came in, because while we were typing it, it seemed to make a whole lot of sense. And as I was trying to teach it, it kind of like stood out and said, So you will often see that the questions are adapted and changed a little bit from time to time. So it's very similar to what you had.
Awesome. Okay,
Yeah.
grade 10s. We've had such an awesome show. Thank you so much for learning more, learning extra. Grade 11's you next, so stay tuned. See you grade 10, same time, same place next week. Bye.